Okay, so our today's topic is nitrogenous bases. That is, particularly we are talking about primary, secondary, and tertiary amines. Okay, so nitrogenous bases in these first we classify them. So amines are first aliphatic amines. Aliphatic amines in which we have alkyl groups like methyl, ethyl, propyl, isopropyl, tertiary butyl. This group is called methyl. This is ethyl. What is the name of this group? This is isopropyl and tertiary butyl. Means if we have alkyl groups attached to the nitrogen, that is called aliphatic amines. And aliphatic amines, you can see, sorry, if nitrogen is attached to only one carbon atom, that is called primary aliphatic amine. If it is attached to two carbons, that is secondary aliphatic amine. If it is attached to three carbon atoms or three alkyl groups, that is called tertiary amine. Now aromatic amines, if nitrogen of the amine is directly attached to the ring, pH means phenyl group, so that is called aniline. If NH2 is attached to CO group first and then alkyl, that is called amide. And if NH2 group is attached to C double bond NH, instead of C double bond O, we have C double bond NH, that is called amidines. That is not in our syllabus, but there are questions which are asked during the exam, that strength of base when NH double bond NH is attached to it. Basic out of these is, which one is most basic? Yes. So because in this case lone pair is always intact, at least one lone pair. If it is in conjugation, you will get two nitrogen containing compounds, say C single bond N H, it is like this, or so that's why fourth one is most basic. And then aliphatic amines, because R group has plus I effect, alkyl group has plus I effect. That's why aliphatic amines are most basic out of aromatic, amide, and amides are least basic Why is it so? Because you know, when we have, same is the case with aniline. What is the hybridization of nitrogen here? Again it is sp2, because this lone pair is in conjugation with pi bond. Okay. Now see, first case, CH2NH2 is attached to cyclohexyl group. Here CH2NH2 is attached to phenyl group. So cyclohexyl has plus I effect, but phenyl group has negative I effect, because here carbon is sp2 hybridized, this carbon is sp3, and you know sp hybridized carbon is more electronegative than sp2 hybridized carbon, which in turn more electronegative than sp3 hybridized carbon. So cyclohexylamine containing primary amine is more basic than this benzylamine. Now out of ammonia, hydrazine and hydroxylamine, ammonia is most basic. Why is it so? Because you know, when we have NH2 attached to hydrogen, second is NH2 attached to NH2, and then OH is attached to NH2. So this OH group has this minus I effect. Again NH2 has minus I effect as compared to hydrogen. We compare it with hydrogen. That's why ammonia is most basic, then it is hydrazine, and last is hydroxylamine. Ammonia, yes, ammonia, ether, alcohol, water. So if we compare their basic strength, you know, nitrogen is less electronegative than oxygen, so nitrogen can donate electrons easily. So ammonia is more basic than ether. Now ether is more basic than alcohol. Why is it so? Because there are two alkyl groups which release electron towards oxygen, you know, because there are only oxygens. So we are comparing the electron releasing effect. If electron releasing effect increases, basic strength increases. So plus I effect of two alkyl groups in ether, only one alkyl group in alcohol, and there is no alkyl group in water. So ammonia is more basic than ether, ether is more basic than alcohol, alcohol is more basic than water. This is most interesting case, because in first case nitrogen is attached to 3 carbons, it is also attached to 3 carbons. That means both the nitrogens are tertiary, but first nitrogen is attached to cyclic groups, so it becomes more compact, therefore lone pair is more available for donation. But in second case nitrogen is attached to an open chain, that's why it can occupy more space, and therefore donation of lone pair, because if it donate electron to one which accept it and which come close to it, because it will not go to the acceptor, acceptor will come close to it. So to come close to it, it should be sterically less hindered. So that's why more compact amines are more basic than open chain amines. That's why it is written cyclic amines is more basic than acyclic. Acyclic means open chain, if degree of nitrogen is same. Okay, so what is the, now there are series of questions. What is the order of basic strength? Okay, then first of all see the degree of amine. This one is primary amine, this is secondary amine, this one is tertiary amine, and in first case what is the hybridization of nitrogen? That is also important. Hybridization of nitrogen, sp3 sp3, they have same hybridization, but in this case what is the hybridization of nitrogen? Oh, sorry, so it is sp2 hybridized. That's why fourth is least basic, fourth is least, and second is most basic because it is secondary amine. And then it is tertiary, and at the end it is primary. Secondary, tertiary, primary. Whenever we have bulkier alkyl groups, order is secondary, tertiary, primary. Same is the case with ethyl amines. But in methylamines, I have already discussed it. In methylamines, what is the order? Secondary, primary, and tertiary. Okay, next, what is the order of basic strength here? Yes, first one, what is first one is secondary because two alkyl groups are attached. Second one, it is tertiary. And this one is primary. But see, it is in ring structure. All are in. So order is secondary again, secondary, tertiary, and primary. So secondary, tertiary amine whenever there is a bulkier alkyl groups. Yes. What is the order of basic strength in this case? Tell me most basic. Which one is most basic? Yes. Obviously, it's Bromamide. लेके आऊँगा मैं, हाँ लेके आऊँगा, हाँ मैं लेके आऊँगा. Yes beta. So most basic is fourth and least basic is first. And then this one, because CO group, say this one is more electron withdrawing because there are electron withdrawing, more withdrawing effect than CO. Then this ring all have resonance effect, right? Minus R effect. But S double bond O, S double bond O, that has more minus R effect than C double bond O, which in turn more than phenyl. So fourth is most basic and first one is least. Yes, which one? Third one is least basic because this phenyl ring, benzene ring, lone pair is in conjugation with it, right? So that's why third is least. And phenyl group here, it shows minus I effect. Here also shows minus I effect, but my inductive effect decreases with distance. So I effect is, minus I effect is more in second than first. And here it shows minus R effect because NH group has plus R effect. So it is first is more basic than second, second is more basic than third. Okay, now yes, very good. Yes, because now you know all the phenyl groups can show resonance and it is opposite to the means lone pair is always involved in resonance, more involved in this case than this, and least is in first case. So lone pair is least involved in resonance in case of first. So that's why first is more basic than second. Second is more basic than third one. Yes, now yes, two CO groups, one CO group, one CO group, but here also it is in resonance. This is in resonance with ring only. It is not in resonance with it. Okay. Why not fourth? Say fourth because in fourth NH group is involved in resonance with ring only, and here it is involved in resonance with CO group. You know, CO group has more effect than ring. That's why fourth is more basic. CO group has more withdrawing effect. In first case, two CO groups, here one CO and one ring. Got it? Okay, now let us talk about substituted anilines. If aniline is attached to electron releasing group, electron releasing group means it increases electron density on the aniline. So it will increase the basic strength, means it will increase Kb. If we have electron withdrawing groups, electron withdrawing group withdraw electron density from the ring, therefore decreases the basic strength. Here it increases, releasing groups increases basic strength, plus M hyperconjugation plus I, withdrawing minus M minus R, plus M plus R, that is same. Now there is ortho effect. What is that effect? That if a group is attached at ortho position except NH2 and OH, because NH2, OH, first of all they are small groups and they are also involved in hydrogen bonding with NH2, so they do not experience such ortho effect, but other groups except OH and NH2, they are mostly weaker bases than aniline itself. Why is it so? Because the bulkier group will cause steric hindrance, and therefore the group cannot reach at that point. Ortho substituted, that causes hindrance due to size, and therefore, because you know any group which approach nitrogen can accept its electron and then it is able to donate it, but if bulkier group is attached at ortho position, then due to steric hindrance that will not donate the electrons easily, and even if it is donated to H plus, that will not be solvated because hydrogen bonding is inversely proportional to steric hindrance. If hindrance increases, hydrogen bonding decreases, and you know solvation play a very important role while deciding the no, because say after accepting H plus, if hydrogen bonding is more, means that cation is more stable, so that will increase the basic strength. Okay, that's why primary amine is more basic than in methylamines. Primary amine is more basic than tertiary amine, right? Yes, there is an NO2 group. NO2 group, you know, nitrogen is more electronegative than carbon, that's why it has minus I effect, and NO2 group has pi bond, I told whenever ring is attached, benzene ring is attached to an atom which has pi bond, directly attached to the atom which has pi bond will show minus R effect. Means it is strongly electron withdrawing in nature. So you know NO2 group at ortho and para position will show minus I and minus M effect, and at meta position it will show only minus I effect. So all the three are electron withdrawing, and that's why they are weaker bases than aniline. But electron withdrawing effect is least in B, and withdrawing effect is maximum, and in addition to that, due to ortho effect, A is least basic. So what is the order? D should be most basic, then it is B, then C, and at the end it is A due to ortho effect. Now if group has only minus I effect, like CCl3, minus I, so tell me which one has maximum minus I effect? I told effect, inductive effect decreases with distance. So NH2 group is closest to CCl3 at ortho, then meta, and it is far away from para. So tell me what is the order of basic strength? So aniline is most, then it is para, meta, and ortho, because minus I effect is maximum at ortho position. Group having minus I effect and plus M, you know chlorine is more electronegative, that's why it has minus I effect, and atom directly attached to the ring has lone pair. Whenever atom directly attached to the ring has lone pair, it will show plus M, or we can say plus R effect. But in halogens, minus I is dominating over plus R, and that's why minus I effect decides the basic strength. So that is same. Aniline. Now groups having plus I and hyperconjugation. See this methyl group, it is at ortho position, it has plus I effect and hyperconjugation. Methyl group at para position also have plus I and hyperconjugation, but hyperconjugation is dominating at para position, and at ortho position, due to ortho effect, it has less effect. At meta position there is only plus I effect. So what is the order of basic strength? They are called toluidines. That means most basic is para and least basic is ortho due to ortho effect, and then it is para, meta, aniline, and ortho is least because of ortho effect. There is no other effect contributing. Plus I and hyperconjugation is not contributing here. Otherwise it should be para, ortho, meta and then aniline. But it is para, meta, aniline and then ortho due to ortho effect. Amides, I just told you that CO group has resonance, and due to that lone pair is involved in conjugation, and you know lone pair, if it is an oxygen, it cannot donate because oxygen is more electronegative than nitrogen, and that's why it can hold negative charge, so its donation tendency decreases, and that's why it is less basic than amines or even anilines. Now amidines, hybridization of nitrogen may be sp3, sp2, spc, this one, X and Y. If see H plus ion is accepted by NH2 group, it becomes positive, NH3 positive, and there is no resonance at all. But if H plus is accepted by NH, then still there is resonance. That means it is more stable. So what it means? See, hybridization of both the nitrogen is sp2, but in NH this lone pair is in sp2 hybridized orbital, but in NH2 this lone pair is in 2p atomic orbital, because that is a part of pi electron cloud. This NH2 containing lone pair is a part of pi electron cloud because it is in conjugation with pi bond. Got it? Like this. So both the nitrogens are sp2 hybridized. Lone pair of most basic nitrogen जो है, that lies in sp2 hybrid orbital because it is localized. This lone pair is localized, but this lone pair is delocalized because it is involved in resonance. This lone pair is not involved in resonance. So see, both are sp2 hybridized. In NH, in case of Y, this is in case of Y, it is sp2 hybrid orbital, but this one, it is in 2p atomic orbital. Here lone pair is localized, but in this case lone pair is delocalized. That's why basicity of Y is more than X. And if it is like this, see NH2, NH2, double bond, NH, it is NH, sorry, then it is most basic because at least one nitrogen has lone pair, even two in all the cases. Heterocyclic compounds, pyridine. So pyridine, you know, it is aromatic, and this lone pair is in sp2 hybrid orbital because that is not involved in conjugation and it is aromatic. Pyrrole, in case of pyrrole, this lone pair is in 2p atomic orbital. It is involved in conjugation, it is involved in resonance, complete delocalization of electron takes place. That's why pyridine is more basic than pyrrole, because in pyridine you can see lone pair is intact, but in case of pyrrole this lone pair is not intact, that is a part of pi electron cloud, that's why it has 6 pi electrons. So it is a very weak base, because if it donates this lone pair it becomes non-aromatic, and you know aromatic compounds are more stable. See the order: pyridine, aniline, pyrrole. So pyridine is most basic, aniline is at the second position, and pyrrole is least, because this lone pair is not at all available on nitrogen. It is, though it is in 2p atomic orbital, it is also in 2p atomic orbital, because but in this case even if it donate lone pair it remains aromatic. If it donate it remains aromatic, but if by chance pyrrole donate this lone pair it becomes non-aromatic, and that is not possible. These two, pyridine and aniline, both remains aromatic even after losing electrons, that lone pair, but pyrrole will not afford to donate, because if it donates this lone pair it becomes non-aromatic. So that is not feasible. Yes, what is the order of basic strength? Fast, this is very easy question. D will be least basic, because lone pair is not at all available for donation. A will be most basic, because these carbon atoms donate electrons to it. See, A and C both, in both cases nitrogen is sp3 hybridized, so obviously they will donate more. Therefore A and C, but in C there is an oxygen atom that will withdraw electrons to some extent, and that's why A is more basic than C, and then it is B and D. Yes, what is the order of basic strength here? Which one is most basic? First one is most basic and then followed by second, because it has also two nitrogens. And which one is most basic? It's sorry, out of 3 and 4. See, 3 is sp2 hybridized, 4th is sp3. Yes, first, second, fourth. Then it is third or fifth. Yes, because in third lone pair remains intact, but here lone pair is delocalized. So it is first, then second, then it is fourth, third, and then fifth. Because here both are sp2 hybridized, but here lone pair is intact. Lone pair is not involved in resonance, but here lone pair is involved in resonance. it is in 2p atomic orbital, it is in sp2 hybrid orbital, this lone pair. Yes, 1 XYZ. Okay. X or Z? Yes, but in this case, if it donate this H plus to H plus, it remains aromatic. But here, if it donate, then yeah, this ring becomes non-aromatic. So it should be Y, X, and least is Z. Okay, so this is all about amines and its derivatives. So now amine is complete in all respect. So you should do the questions related to amine, its basic strength, its reactions, chemical reactions, preparations. Okay, and if you find any doubt, please do send. You can send, I will take up in next class. Oh, sorry. We will start GOC still, we have topic of GOC. Yes, phenol, carboxylic. Okay. Okay. Yes, yes.